Hi guys, in this video I'm going to explain about one of the most frequently asked interview question about the traceroute command. So we'll see why do we use traceroute, how traceroute works, what is the TTL value used in the traceroute, will the source and destination IP changes in the traceroute process, how the source knows the destination IP is reached, and what protocol used in a traceroute. So Traceroute is a very powerful tool when you are doing the IP reachability troubleshooting. So these are some of the expected questions in a networking interview related to Traceroute. I'm going to use Cisco Packet Tracer tool to explain about how the Traceroute works and also how to find answers for all these questions. So this is my Cisco Packet Tracer tool. So I have some 5 routers 0, 1, 2, 3, and 4. I'm going to initiate a trace from 10.10.1.1 to the destination 20.20.1.2. So when I initiate a trace, the packet travels via router 1, 2, 3, and 4. And we will see how traceroute works when I initiate the command traceroute from router 0. So before I start doing that, I will just quickly explain why the traceroute is used basically. Let's say when you initiate a ping from router 0, that is 10.10.1.1 to the destination 20.20.1.2, and let's say the ping fails, you can give a traceroute command to find where exactly the packet getting dropped in the path, right? So basically when you initiate a traceroute, the result shows what are the hops it went through to reach the destination. Let's say when I initiate a traceroute from 10.10.1.1 to the destination 20.21.2, the packet reaches router 1, and the traceroute, the first hop you will see this IP, then the router 2, the second hop, and third hop you will see this IP, and finally the destination router. So basically traceroute gives the information what are the hops and its IP address it traverses to reach the destination IP address. So the traceroute commands reveals the IP address of the devices in the path to reach its destination. So I will first explain the theory, what happens when I initiate the traceroute from router 0, that is from 10.10.1.1 to reach router 4. When I give the command traceroute and then this destination IP 20.21.2 in the router, the source router, the traceroute process initiates a ICMP request packet to this destination, that is 2021.2, and it will set the first packet of the traceroute. It will first set the TTL value as 1. So the packet sent out to the immediate next hop. Basically, the router checks in the routing table for the entry 20.20.1.2. It checks the next hop IP address is 10.10.1.2. The process sends it to the next hop IP address, that is router 1. Router 1 receives the packet. The destination IP, it's there in the routing table or not, it will check. Let's say if the routing entry is there, it knows to reach 20.21.2, it has to send the packet out of this interface. But before that, it will reduce the TTL value by 1. So the default behavior of a router is that when it receives the packet and before it forwards to the next router, it will reduce the TTL value by 1. Since this particular traceroute, the first packet that we sent with the TTL value 1, it sends a message back to the source that the TTL is expired. So that is the ICMP TTL expired message from router 1 to router 0 with the source IP of 10.10.1.2 and destination 10.10.1.1. Now this router 0 receives that packet and it notes down the source IP 10.10.1.2 and it notes down the first hop in the path to reach the destination is 10.10.1.2. Now it will send by default 3 ICMP packets in a traceroute output. I will show that, and after that it will send another ICMP packet to the destination 20.21.2 with the TTL value 2. So now this time again the router source router sends the packet to router 1. This time router 1 receives it and it checks the routing table. It knows the next step to reach 2021.2 is 10.10.2.2, that is router 2 IP address. Now it reduces the TTL value by 1. Now the TTL value becomes 1 and the packet is sent out of router 1 and router 2 receives it, and router 2 also checks in his routing table for the destination IP 2021.2. It knows to reach 20.20.1.2 it has to send the packet out of this interface to reach router 3. The next stop IP will be 2022.2. But before it sends the packet out, the default behavior is to decrease the TTL value by 1, and when it does, the TTL value becomes 0. So now router 2 will send an ICMP TTL SPAID message back to the source, that is 10.10.1.1. Now this ICMP TTL SPAID message will be sent from router 2 to router 1 and router 1 to the source 10.10.1.2. So now this ICMP TTL SPAID message sent with the source IP address of 10.10.2.2 and destination IP address 10.10.1.1. So now the source knows the second hop in the path to the destination is 10.10.2.2. Now the source router will again send the ICMP to the destination 2021.2 with a TTL value of 3. Now the same process continues. Router 1 receives it, reduces the TTL value, makes it 2. Router 2 receives it, reduces the TTL value by 1. The TTL become value 1 now. It reaches router 3. Now router 3, it knows to send the packet to 2021.2. It has to send over this interface which is directly connected, but this time again it will reduce the TTL value by 1, and now the TTL value become 0. Router 3 will send a TTL SPAID message with the source IP address of 2022.2 and destination IP 10.10.1.1. So that packet, that ICMP TTL SPAID message packet goes to router 2, 1 and then reaches the source router. Now the source router notes down the IP address of the device that responding the TTL SPAID message, that is 2022.2. So it notes down the third hop in the path to reach the destination is 2022.2. Now it will send the ICMP packet with the TTL value 4, and router 1 reduces by 1, it becomes 3. Router 2 again reduces by 1, it becomes 2. Now router 3 receives it and it reduces by 1. Now the TTL will become 1 and then it reaches to router 4. Now router 4 is the actual destination. This packet in the routing environment, it will be, routers will use when it initiates, it's actually sends with a UDP packet with a random port number. Basically, I will show in the packet capture. When that packet reaches router 4, the router 4 will send a port unreachable message. So that packet again goes back to router 3, 2, 1 and then the source router. When the source router sees the port unreachable message, it knows it has reached the destination to which the trace route was initiated. So this is the process. Now we will see in the simulation mode. So this is the router CLI. I'm going to initiate the trace route to 20.20.1.2. That is our destination IP 20.20.1.2. So the trace route is initiated. Now let's see in the simulation mode. You can see it's basically a UDP packet. I'll open up and see the trace route process starts the next trace. The device encapsulates the PDU into a UDP segment. And you can see it's basically an IP packet with the source IP 10.10.1.1, destination 2021.2, and UDP. You can see the destination port number 33434. Basically, since UDP packet such a random port number, so that basically there is no service listening on this port number. That's why you will get a reply when it reaches the destination. Actually, when it reaches 2021.2, you will see a port unreachable message. Okay, now we'll see the next command. If I give, it will initiate ICMP packet. You can see this ICMP packet. Okay, we'll see this one. This is the second packet. The second packet, which is going from, you can see in the screen, going from 0 to 1. That is from 0 to 1 actually. We'll open up this packet and see. You can see the TTL value set to 1. That is the first packet going out. So when it reaches the router 1 sends the ICMP TTL expired message. You can see the device sends an ICMP TTL expired message. And in the router, I just want to show that. You can see there is no entry right now. But when the TTL expired message reaches the source router, you will see there is an entry. Okay, now it reaches. And you can see it notes on the first hop, that is 10.10.1.2, sends the reply TTL expired, and this is the one packet, one ICMP packet. Totally it will send 3 ICMP packet for each iteration of that cycle for one particular hop. You can see that again it sends, it will send ICMP reply. Now you will see that second packet, how much time it took. Now the third one. So when you get an ICMP expired reply message, you will see all the. So for each hop, basically it will send 3 ICMP echo request, each with the TTL value 1. So now it will send an ICMP packet with the TTL value 2. So this packet, if you open and see, you can see the TTL value is set to 2, and the source IP, destination IP remains the same. Now this packet will reach router 1. So router 1 have an entry to reach this destination 2021.2. So it will send it to router 2, but it will reduce the TTL value from 2 to 1. So this packet, if I open and see, so you can see it reduces the TTL value 1, and then it will be sent to router 2, and router 2 receives it. It knows there is an entry to reach 20.20.1.2, but since the TTL value is 1, when it reduces the TTL value by 1, it becomes 0. Then it becomes TTL expired basically. You can see the packet TTL expired. The device sends an ICMP time exceeded message back to the sender and drops the packet. So it will like do for like 3 iteration. Now let's see the router. Right now there is no entry. When it reaches the source router, it will note down that IP. That is router 2's IP address 10.10.2.2. You can see it notes down 10.10.2.2. That is the first ICMP packet. Now again, it will totally send 3 packets actually. And one more thing to note down is that this ICMP time exceeded message, when that ICMP reply packet comes with the time exceeded message, that TTL will be like 255. You can check that here. You can see when the packet coming from the source 10.10.2.2, that is router 2's IP address 10.10.2.2, the reply becomes a 255. When it reaches here, it becomes 254. Like that, it will keep reducing. You can see the second packet with its millisecond, how much time it took. Now it sends one more ICMP packet, the third one, and then it replies back. So you can say all the 3 ICMP packet time detail is given. Now it will send another ICMP packet with the TTL value 3. You can open and see that. You can see the source IP 10.10.1.1, destination 2021.2, and the TTL value is 3. Now the packet goes to router 1. The TTL become 2 here. Let's confirm that. Okay, it's still 3. It's not at. removed it. When it sends out, it becomes 3. Yeah, it reduces by 2 here. Now the packet is sent out to 3. So this packet, when you open and see, it will be 1. So the TTL becomes 1 when reaches router 3, and router 3, before it's sent to router 4, it has to reduce it by 1, so TTL become expired. And you can see the device sends an ICMP time exceeded message back to its sender. So this packet, when it reaches here, you can check the header. So the TTL is 255. The source IP is 20.20.2.2, which is nothing but router 3's IP address. You can see the source IP 20.22.2. That is router 3's IP address, interface IP address 20.22.2. And it's sending to the sender destination IP 10.10.1.1, which is the actual source where the trace was initiated. Now when it reaches router 1, we'll see the source. The source will be same, destination will be same. The TTL is reduced to 254. Now if you open the source router, you can see it notes down the third hop to reach the destination 20.22.2. That is router 3 IP address. Now it will send one more packet. So totally 3 packets will be sent. So once all sent and received, you can see it took like 6 milliseconds to reach the third hop and then get the reply back. Now it will send ISMP with TTL value 4. Let's open up and see the packet itself. We can see the TTL value set to 4. Source is 10.10.1.1, destination 20.20.1.2. So it goes to router 1, TTL reduces 1 by there, and then 2, and then 3. Now in 3, let's open this packet. You can see it is all going like a UDP packet, but if you open up and see and the TTL value, how it's going to reduce there, the UDP source port and destination port actually. Now the packet is going to reach router 4, which is the actual destination. We will see what happens there. Uh, so far we will see a cross mark on the ICMP packet itself because it says ICMP TTL expired. Now first time you will see a cross mark on the green. Green represents the UDP packet. We will see what happens there. So the interface receives the frame and it checks the entry is there for the MAC, and IP entry is also there, and there is no service running listening on this port. That is the destination port 33434. The device drops the segment. That is for this particular destination port, there is no service listening here. That is expected actually, and ideally it sends a, you can see the device sends back an ICMP port unreachable message. So when the source 10.1.1 receives this ICMP port unreachable message, it knows that the traceroute process reached the actual destination IP, and we are getting, that's the reason we are getting the ICMP port unreachable message instead of ICMP time exceeded message, the TTL expired message actually. And again that will happen thrice, and you can see the actual destination 20 dot, you can see the traceroute initiated for 2021.2 that finally re-entered here. And also you can see this router in the path. Let's open up and see the ICMP TTL values. It keeps reduces in the each hop in the reply. The default value is 255, and the each hop when it replies it gets reduced. Only thing to note here is when the the trace route is initiated from this router, that time we will deliberately change the TTL value like 1, 2, 3 on each iteration in order to find the hops, what are the hops it passes to reach the destination. But the ICMP port unreachable or ICMP time exceeded reply that is coming from the each hop in the path, it uses a default TTL value that is 255. Only the traceroute process sets the TTL value when initiated from the source, like 1, 2, 3 for each of the hop until it reaches the destination. That is the default behavior of the traceroute. See, okay, so this is the last one. Port unreachable message is coming back to the source router. Okay, now you can see the traceroute completed in the source to reach the destination 2021.2. It has gone through 10.1.1.1.2, that is this router 1 interface IP address. The second hop is 10.2.2, that is router 2 interface IP address 10.2.2. Then the third hop is 2022.2, which is nothing but router 3 interface IP address. Then the final destination IP 2021.2. Now coming back to the possible questions for traceroute, like why do we use traceroute? That I explained in the beginning, like to find what are the hops in between we travel to reach the destination IP. We'll use the traceroute, and mainly we use for troubleshooting purpose, like when you initiate a ping for a destination IP which is not directly connected, and if the ping is not working, we can initiate a trace route to that particular destination, and we can see where exactly the ping drops. For example, when I initiate a ping from router 0, the ping is failing, and when I initiate a trace route from the source, that is 10.1.1.1 and sorry 10.10.1.1 and destination 20.20.1.2, and the trace route drops, um, let's say the trace route drops at 10.10.2.2. Like in the trace route you see 10.1.2 and 10.10.2.2, and after that the trace route is completely stopped, you don't see anything. Then you can suspect some problem between router 2 and router 3, because if the IP reachability is there between these two routers, there can be another entry for 20.22.2. So in the trace route, if you see only 10.10.1.2 and 10.10.2.2, it means the router 1 and router 3, the IP reachability uh, till router 1 and 2, it is there. And after that, between router 2 and 3, there might be some problem. Maybe this connection is completely down, or can be due to some routing issues. It can be anything basically. We are not able to reach till router 3 because 2022.2 entry is not available. I'm just saying, like in the routing, in the trace route, you see only this 10.10 to 1.2 and 10.10.2.2, and after that you see only like stars. You don't see any entry coming apart. So that basically signifies that the router able to reach only first two hops, and after that there is no IP reachability. It could be because of many reasons actually. And the second question is like how Traceit works, that I explained before showing the demo in the packet tracer. And mainly the candidate will be tested with what is the TTL value used in the trace route. So this question, when a trace route initiated from the source, the first ICMP packet goes with TTL value 1, and after that the second time when you get a reply TTL and title SPAD, the second time you send the ICMP packet with the TTL2. So basically the source router from where you are initiating the trace route The TTL value is set by the traceroute process, depends upon the reply it getting, right? So the TTL value is not a constant one. Basically, that is keep changing, starting from 1, 2, 3, depending upon the number of hops in the path. But when you asked about the TTL value of a ICMP packet, it generally, as I showed, it shows only 255. That is, you can say when the TTL time exceeded ICMP packet, that is a reply packets coming from the each hop, the TTL value is 255 and gets reduced on the each hop in the path back to the source. That is something expected, default value. And so that is the difference when the question is asked about the TTL value. The source router where you initiating the trace route that can change the TTL value, but the packets that are coming back to you, either TTL, ICMP, TTL expired message or ICMP port unreachable message, whatever the default value the ICMP protocol uses, it uses the same value. And will the source and destination IP changes in the trace route process? The actual source and destination basically remains same, but this ICMP TTL expired messages and ICMP port unreachable messages, you can see the source where the TTL is getting expired, that particular router source, that interface IP address will be your source in the reply packets. So basically, you can say that a particular each hop, that particular hop sets its own IP address as a source IP address to inform the source router that the TTL is expired like that. So the IP, you can say it is changing on the reply packets so that the source knows to reach the destination. We have to go through these hops basically. So basically, from the source router perspective, when the trace route is initiated, the source IP destination IP remains the same. Only when the TTL expired messages, you're getting from each hop, the ICMP protocol sets the source IP of the interface which is sending the reply. So how the source knows the destination IP is reached, like I showed in the packet tracer, when the source router receives port unreachable message, it knows only when the destination IP is sending that reply, right? It says that basically we reach the end destination. So the device which is going to send a reply, basically that packet which you initiate from the trace route, whatever the destination IP you set, we have reached the destination IP, and that destination IP we are sending a UDP packet with port number 33434, and that destination IP address, the device not listening on that particular port number. So only that particular destination IP can send a reply back the port ICMP port unreachable message, not any other device in the path, right? So so that's why the source knows that whenever it receives that port unreachable message is received, the source knows that a particular destination IP we have reached, and that particular destination IP not listening on any port, hence it is sending port unreachable message. So basically, the source router knows how we reach the destination by looking at that ICMP port unreachable message. So what protocol used in the traceroute? That is, looking at packet tracer, you can easily say that ICMP is the protocol the traceroute uses, and it uses it by changing its CTL value from the source router. So you can simply say ICMP is the protocol basically used by the traceroute in order to find each hop in the path by changing its TTL value from the default TTL values. So these are some of the possible questions that can be asked related to traceroute. But once you know how the traceroute works completely, step by step, and at each point, what will be the source IP, destination IP, when the packet is initiated from the source router, and when the ICMP TTL expired message comes back to the source, what will be the source IP and destination IP? You should be able to, the person taking interview can stop you at each of these point and can question what will be the source IP, what will be the destination IP, and what will be the TTL value at this particular point when router 2 sends ICMP time accelerated message back to router 1, so like that, the person can ask the questions just to make sure the candidate understands the complete trace route process. And like I said, when the trace route is not fully getting completed from source to destination, and looking at the trace like in the entry, how you can determine up to which point the packet has reached and where exactly the drop is happening. Like one example I told, like if you see only these two entry 10.10.1.2 and 10.10.2.2, and after that you're not seeing 20.22.2, it basically proves the route packet is able to reach till router 2. And after that, right now in the diagram I show only one link, but in the real time there can be multiple links to reach the destination. So router 2 basically not able to forward the packet to the destination. That will be useful when you actually troubleshooting the IP reachability issues. You can log into router 2 and then do all the troubleshooting why it's not able to forward the packet till 2020.1.2, the actual destination. So it's basically a very powerful tool for troubleshooting. So definitely this question can be asked in an interview, like how the traceroute works, and when you explain the process, you should be able to explain each and every step how the source determines um, each hop to reach the destination. Thanks for watching the video, and don't forget to subscribe to my channel and hit the bell button so that next time when I upload another interview questions, you will get an alert.